As a member of the EU, by the year 2020, Ireland has committed to increasing our use of renewable energy by, among other things, harnessing the abundant wind energy this island has to offer. This requires the design and construction of wind farms. These large wind turbines on these farms are often built on the side of very poor soil quality, often on hillside bogs. An alternative option to this is to construct offshore wind turbines, one such example being the Arklow wind farm off the coast of Wicklow. There are many foundation types to build for a wind turbine, with single piles being one of them. The challenges an engineer faces is to design a foundation strong enough to resist the forces of nature while also providing a cost-effective solution. It was these challenges of design that led me to select my final year project on the analysis of model piles subjected to lateral loading. My wind turbine pile was represented by an instrumented model pile made from a hollow aluminium pipe, and I designed a miniature car jack-like tool which can be inserted inside the pipe to install the strain gauge instruments.
Firstly, after we had selected our pipe that we were going to install the strain gauges on, we proceeded to etch it. Secondly, we needed to degrease the inside of the pipe. We soaked a sponge in acetone and began to scrub the inside of the pipe. Any acetone residue left on the inside of the pipe was cleaned by using a neutralizer. In order to install the strain gauges on the inside of the pipe without damaging the pipe, we needed to manufacture our own installation tool. The design of this tool was inspired by a paper by Joseph Caliendo of the Utah State University. We modified his design slightly and based mechanical action on that of a car jack. The strain gauge wires are thread forward through the pipe. It is then carefully placed down and pressed up against this double-sided sticky tape. Once one strain gauge has been installed, the tool is spun around so a second strain gauge can be installed on the opposite wing. This allows us to install two strain gauges diametrically opposed so we can measure tension and compression. The adhesive we used to bond the strain gauges on the inside surface of the pipe was AE10 epoxy. Once the epoxy had been applied to the top side of the strain gauge, we just inserted the rod up to the required distance inside the pipe. Once the installation tool had been inserted the correct distance, we twisted the screw to expand the arms and pressed the strain gauges against the side of the pipe. We let this sit then for 24 hours overnight to allow maximum time for the curing of the epoxy. The following morning we would come in and retract the arms.
The model pile was then installed inside a large container of sand. The head of the pile was allowed to extrude above the soil level. The wind and wave action on the model pile was simulated with the use of a car jack mounted sideways connected to the pile head. The strain gauges were connected to a computer and measurements were taken throughout the entire test. The deflections at the pile head were also measured during testing.
From the testing, the bending moments measured were plotted on a graph versus the depth of the pile. They show a maximum moment occurring at a depth of approximately 5 to 6 pile diameters down the pile length. Not enough time was afforded to validate these results with further testing and data gathering. The method of attaching strain gauges to the inside surface of a small diameter pipe proved very successful and can be repeated for model piles of various diameters and lengths.